So in section 6.2, we'll get into some of the deeper proofs. And again, I would like you to take a minute here to memorize these definitions. We had talked about them already in the first section. So please take some time to summarize everything, write it down on a piece of paper or something like that, and try to take a minute to memorize it. Okay. The first one is the definition of the union. The second one is the intersection. The third one is set difference, the complement, and finally the n-tuple. Okay, so in the next few minutes, we will be proving together some of these properties written down in theorem 6.2.1. So for example, the very first one that we're going to prove is that the intersection of A and B is inside of A. If you kind of think about it, if this is the set A and this is set B, the intersection is the space in between right there. And obviously that is part of the circle of A. So it kind of makes sense when I draw the diagram, but how do I go about proving this actually? Okay, so to prove this, we're going to use the proof procedure that we described in the very first section. So we're going to start with let A and B be any sets in this case. There's no restriction on the sets A and B. And what I would like to show you right now is, I want to show that A intersect B is a subset of the set A. And the way I'm going to do that is I'm going to grab an element X from this and show that it's part of the A automatically. Okay, so let X be an element of A intersect B. By definition, the X has to be inside of A and the X has to be inside of B. How do I know that? I know that by the definition up here, the one that's called intersection. If you're in the intersection, then you're in the first set and automatically in the second set. So if you're in the intersection, you're automatically in the first set and also the second set. Okay, so therefore, we can say, in particular, we can focus on the first thing that we wrote, which is that X is an element of A. So we are finished. Why are we finished? Because we have to show that finished. We had to show that if you're in the intersection, then you are automatically inside of the A. And we have done that by showing that X comes from the intersection. We can convince ourselves that X comes from the A in particular. So QED of the first proof.